Hi, this is a short video on the human eye and corrective lenses for nearsighted and farsighted people. So the basics of the human eye are that we have an eyeball and there's a lens in the front of the eye. And so if we have an object like a tree in front of our eye that we're looking at, the image of the tree is formed on the back of our eyeball called the retina. And so we'd see an image of the tree back here. And for a normal person with good vision, the lens creates that nice sharp image of the tree right on the retina. And so everything is nice and in focus. But many of us don't have good vision. Myself, I am nearsighted. So my eyeball, it turns out, is a little bit longer than normal. So nearsighted people have an eyeball that's slightly longer than normal, which means that an image is formed in front of the retina. So here's our clear image of that tree. So it looks fuzzy to me because by the time it hits my retina, the rays aren't perfectly converging. They're a little bit spread out. So what we do for people who are nearsighted people, we need to spread those rays out a little bit so that they don't converge in front of the retina, they converge on the screen of our eye, the retina. So we put a diverging lens in front of our eyeball, and that diverging lens spreads the rays, oh, I'm doing this wrong, spreads the rays out just enough, there, oopsies, so that we get a nice clear image on our retina. So nearsighted people, that's also called myopia. Myopic people are nearsighted. We need a diverging lens, a negative focal, which means a negative power, because we have power is defined as 1 over the focal. So nearsighted people who, if I take my glasses off, I can see things close up, but I can't see, everything out there is blurry for me. So I see the things that are near to me. I am myopic. We need a diverging lens with a negative focal and a negative prescription in order to fix that correction, to fix the problem. So farsighted people, really not drawn well today. Farsighted people, you might be able to guess, have a shorter than normal eyeball, so that the object out here, the image of it is formed behind the eyeball. So what we want to do for farsighted people, and these are people who can see things clearly far away but not close up, we want to put a converging lens in front of their eye so that these rays converge down more quickly and we get a nice sharp image on the retina like we want. Farsightedness is also hyperopia. So a farsighted person is hyperopic. And a converging lens will have a positive focal length and a positive power. So that's just the basics of how people are nearsighted and farsighted and the type of lens that you would need to fix both of them. In order to figure out the math of the prescription, the power of the prescription needed, we have two different ideas. For nearsighted people, so these are people who can see clearly close up but who have trouble seeing things far away. So we're going to take a fuzzy object that's far away. So we're going to have an object, and by far away I mean like twice the focal length of the eye. So we're going to take an object infinitely far away, which really isn't that far, and we're going to put an image, create an image, a virtual image of that object at the point where I can see clearly. So I'm going to put it at my far point. So the farthest point out that I can see clearly, that's where my glasses create an image. So if we think about our lens equation, mirror equation, same thing, I'm going to have 1 over infinity plus 1 over my far point, and a negative. That negative is very important because it's a virtual image. A real image would have the image formed way back here in my eye. I want to be able to see an image of things out that way. So it's a virtual image, negative di equals 1 over f, but 1 over f is defined as the power. So the power of my prescription is 1 over infinity plus 1 over negative my far point. 1 over infinity becomes 0. So for a nearsighted person, their prescription is actually just 1 divided by negative far point. So whatever the farthest they can see clearly. So without my glasses, I can see clearly about here, which is about 30 centimeters. My prescription will be about 3.3 diopters. That's the unit. The thing you have to remember is that for this equation, you have to have everything in meters. We've been using centimeters a lot. And for this equation to work, you have to turn everything into meters. So make sure you convert. So this is for nearsightedness. And the prescription, the power of the prescription, is just going to be 1 divided by negative far point, farthest they can see clearly. For a hyperopic person, a farsighted person, that's somebody who can see clearly far away, but who can't see clearly close up. So we don't want to take an object that's far away and make it clear. No, they can already see that clearly. So it's the opposite of what we want to do for nearsighted people. Here we want to take close-up objects and make them clear. We want to bring them far away enough that the person can see them clearly. So for hyperopic people, which is farsighted, those are people who can see clearly far away. We're going to take an object close up, and this is defined as the standard human near point, what we expect every human to be able to see. We're going to take the object at 25 centimeters, but we've got to use meters. So we're going to take an object at 0.25 meters, and we're going to create an image of that. We're going to push that image far enough away that they can see it clearly. So we're going to put a virtual image, negative di, at the nearest point that they can see clearly. So this is one of the weird things. Nearsighted people have a far point, the farthest away they can see clearly. Farsighted people have a near point, which is the nearest they can see clearly. So our standard lens equation becomes 1 over 0.25 plus 1 over negative near point equals 1 over the focal, which is our prescription. So for farsighted, it looks like this. 1 over negative near point equals the prescription. So it's a little, one step more complex for farsighted people because you're taking an object a certain distance close. Whereas for nearsighted people, we want something really far away. Infinity, 1 over infinity becomes 0. So this is the equation for nearsighted people. And again, make sure it's in meters. Here is the equation for farsighted people. Make sure it's in meters. And that's how you determine your prescription, if you are farsighted or nearsighted. So questions you might see would be, if a person has a far point of 80 centimeters, what would their prescription be? Or someone's prescription is negative 1.75 diopters. What is their far point, nearsighted far point? So that's the kind of question that you're going to see with the human eye. And you just have to keep in mind these words. Hyperopic means farsighted. Myopic means, let's go, I'll just remind you there, myopic means nearsighted. A farsighted person sees clearly far away. Nearsighted person sees clearly near, close up. Here's the equation for farsighted because we take a close-up object and push it back to the near point. For a nearsighted person, we take an object far away and make an image of it close up where they can see it. And so that's the basics of the human eye. It's not too complex mathematically, but you just have to be able to remember, it's like, am I taking something far away and bringing an image up close? Or am I taking something up close and making an image far away? And that's the basics of the human eye. So, real quick overview. Hope it helped.